So x1, x2, x3 is an arithmetic progression or sequence, all of whose terms are integers. N is then a positive integer, and if the median of the first n terms of the sequence is an integer, we're asked which of the following three must be true. So we really need to split it into two cases here. If n is odd and if n is even. Let's take a look at if n is odd. Then we get some sort of sequence. I'll just write down an example, maybe 1, 4, 7, maybe n is 3 here. So I would get a median in the middle of my odd numbers, it'd be 4. So if I then added an extra 2 on, so 10 and then 13, I'm just going to shift the median along by 1. So because all the numbers in the sequence are integers and the median of the original is definitely going to be an integer, like 4, for example. Yeah, when I do n plus 2, I just move it along 1, it's still going to be in the sequence. So 1 is true for this situation. But if I now look at the median of the first two n terms, so that'd be the first 6, for example. Let's just go back to my little example that I've made. Now I've got 6 terms, and the median would actually be in between the 7 and the 10. So I can immediately see just through this that this is not necessarily true. I can put a little cross there. And then what about the median of x2, x4, x6, and so on? Well, it's just every other term, essentially, starting with the second and the fourth and the sixth. There's going to be n terms again. So because n is odd, it's going to be the middle one. And again, that must be in my sequence. So 1 and 3 are always going to be true when n is odd. Right, odd, tick, odd, tick. Let's now take a look at n being even. So I'm going to have a term a plus kd in my sequence. Remember, the nth term is un equals a plus n minus 1d. So for some particular value of k, I'm going to get the median between two terms in an even progression. Like if you had let's write 2, 4, 6, 8, then the median would be 5. If I went with 2, 5, 8, 11, actually the median would be 6.5. So that's just what I'm investigating here. Any extra conditions we need when n is even. But let's say I've got a plus kd, and then my next one would be a plus k plus 1d. Then to get the median between these two, I would add them up and divide by 2. And this would give me 2a plus 2kd plus d over 2, which is a plus kd plus d over 2. And so for me to guarantee that I get an integer for the median, which is what we're told, we need d to be even. That is a condition here. So now if I want to see if the median of the first n plus 2 terms is an integer, instead of looking at k and k plus 1, I'll be shifting, I've got these extra 2 terms, and I'll be comparing k plus, like if I've got an extra 2, then the median would move to here, just like it did with the odd. And then I'll be looking at a plus k plus 1d and adding it to a plus k plus 2d and dividing by 2. We're going to get the same sort of setup now. We're going to get 2a plus 2kd plus, I could write it as now 3d or as 2d plus d. What I can see is I'm going to get a plus kd plus d over 2. But because we know that d has to be even, this will be an integer. So this one is true for odd and even. Just put a little circle around it. Okay, what about the median of this one when I'm taking every other one? Now we know that the common difference is d for the original sequence, so now it's going to be 2d. So essentially, I've still got a bunch of integers. They are, I'm going to have an even or an odd number of them. If it's an odd number, then I know that it's going to then be in the sequence because it's going to be an integer in the sequence. If it's an even number, then I'm back to having a sequence of integers with a common difference that's even. It's also going to be in the sequence, guaranteed. So I'm not going to go into any more detail on that. This one is also going to be true for even, and therefore our answer is 1 and 3 only.